Okay, gentlemen, we're going to take a look at right where we left off last time. With our logs, base this to what power gives me that. This base to what power gives me that. And we talked about it with log with no base is base 10. And those are the common logs. So I'm going to show two things, and we're going to kind of skip down to another log, the natural log. We did the common log, we did all other logs. Now we got the natural log and then this idea. So if we look here, right, I'll take that away for a sec. We have 2 to this, right? So what happens if the log is the exponent? Well, we were always saying logs are exponents. So this is, what does this mean? Logs are exponents. Well, if I take a look at just what's up here, and I say, well, log base 2 of 8, meaning 2 to what power gives me 8? And that is 3. So if I say this is 2, logs are exponents to the third, that's just 8, that number. So is that always going to be the case if these two bases are the same? Yes, and we can kind of see that again shown out here. Logs are exponents. Log base 3 of 81 is saying 3 to what power gives me 81, and that's 4. So this is 3 to the 4th, which we just saw was 81. So this is a nice idea. If logs are exponents, if I take log and make it an exponent, as long as the bases match, I just get that number as my answer. Okay, and that's what this property says right here. Okay, so that's the first thing. Common logs we did. This was all base 10. Base 10. We saw all these. Okay. Natural log, base E. So just like we have log with no number of 100 is equal, really means log base 10 of 100, right? That's what it means. If there is no number, it means 10. If I see ln, so like not a log, but it looks kind of like a log, ln, that means log base E. So if I have ln of 4, that means log base E of 4. Right? So that's what that means. Log base E, we call it the natural log. Okay? So that's just like our last thing. I didn't get to talk about it after the test, so that's talking about it here. ln means log base E. Log with no number means base 10, and everything else is that number. Same exact properties, everything's the same. If I have an ln as a power of the E, I just get the x. Just like we just saw with numbers and the bases, if I had it with a 10 and a log without a number, same thing here. E to the natural log, they're going to cancel, and I just get out the x. Okay, and here's some more examples, but I kind of want to work on these examples. So first, looking at these. I wrote these kind of different, but let's see kind of why. So we have logs are exponents, as we say a lot. Logs are exponents. And I want to see, so we had just seen if I take a number and I raise it to the log of the same base, they cancel. What happens if I have like this kind of an exponent thing inside of a log? Well, what does this mean? This is my base. Logs are exponents, so I'm looking for my answer. What is my exponent? And how do I get 4 squared? Well, that's just 16. I don't know why we would write 4 squared. How would I get to 16? With a 2. But if you notice, if I didn't change that, if I left that as a 4 squared, that's kind of telling me the answer. 4 squared, that's 16. 4 to what power gives me 16? Gives me 4 squared? Well, it's the 2. It's saying the same thing. Right? So let's look down here. These are the same, the base and this number. Right? And these numbers got to be the same for this to kind of work. Base 5. Logs are exponents. What is the exponent that gives me 5 to the third? Well, that's obviously just a 3. If I were to say, well, that's 125, what's the power of 5 that gives me 125? It's 3. It's always that number. If I have a log of the base that matches this base of an exponent inside of it, they cancel, and I just get that little power in there. Okay, so again, that's based on the idea that logs are exponents, just like we saw up above, except the opposite. Instead of a base to a log, an exponent, right? Log as the exponent. We have an exponent inside the log. Okay, so those are two properties, and this is just showing that they are inverses. They undo each other. So if you want to undo a log or undo an exponent, you need to use a log or use an exponent with the base that matches. That's the key thing. Just like if I want to multiply both sides by 2 or divide by 2, they're going to undo each other. Can't multiply or divide 1 by 2 or 1 by 3. It's got to be the same number. Okay, so if I were to say solve, we want to get to the x in the top. If I have 2x equals 5, 2 times x equals 5, I got to divide both sides by 2. Dividing both sides by 2 is the opposite of multiplying by 2. Over here, the 2 is up here. How do I get it down from up there? Well, since that is an exponent, I want to do the opposite, the inverse of an exponent, meaning log with the same base. So if I take this and I log 2 to both sides, if I log 2 both sides, so just like if I divide both sides by 2 or multiply both sides by 3 or square both sides, same idea where I want to log 2 both sides. And when I do that, just like we saw up here, if the base matches this base, that power is what comes out. If the base matches this base, that power is what comes out. X is equal to, now what about this mess? 2 to what power gives me 5? This is saying 2 to what power gives me 5? Well, not 2. It's like 2 and a little bit. I don't know what that is. It's not a nice number. I know. It's going to be some weird decimal. But that's okay. We can just leave it. At this point, once we start solving, a lot of them we're just going to leave in this kind of generalized log form. It's like radical 11. Just leave it. You don't have to change it to a decimal. Okay? Same thing here. I'll do another example, and we'll kind of go a little quickly with the second half of these. Exponential e. The x is up top. It's an exponential function. I want to get it down. I will have to use the inverse, which is the log. Again, I want to match the base. Base is 3. So I want to log base 3 both sides. Just like if I were to multiply both sides by a number to cancel out, I want to log both sides in order to get it to cancel out. Oops, sorry. Okay? When I do that, just as we saw up above, log and this base match, they cancel, and I just get the exponent to come out because logs are exponents. Logs are the exponent. Same thing, 3 to what power gives me 10? It's, let's see, well, 3 squared is 9. So 2 and a little bit, 2 and some decimal, so we can just leave it. If I knew what that was, I would compute it, but I don't, so I'm going to leave it. Okay? Just like with sine and with radicals, this stays together. You can't break that up. So when I add 3 to both sides, I just get my log base 3 of 10 plus 3. This stays together. Once you have a log, a base, and a number in parentheses, just hold that together. Okay? This one we'll do a little fast. This is base 10. This is an exponential. There's an x in the top. How do I get it out? Log of the same base. This is base 10, so I can just write log. And that means I got to do the same to the other side. 10 to the 2x minus 5. 6. Okay. 10 to what power gives me 6? I don't know, so I know I'm going to leave that. Common log, base 10, I just get out the 2x minus 5. Log base 10 of 6. 10 to what power gives me 6? I don't know. 10 squared? No, it's a small number. I have no idea. So leave it. Some decimal we don't know. Okay, and then just regular steps from here. I'm adding 5 to both sides. Just as we saw, this log base 10 of 6 has to stay together. So I add 5. Divide 2 by the whole thing. Both terms. That's a divide. The log base 10 of 6, again, stays together. And there's my answer. Okay, one more, and then we'll switch to kind of doing the reverse. So this is another exponential, but it's a special one. It's with e. So not using we want to use the log of the same base, which for us is this ln, this new thing we just learned. So if I have base e, I want to do the log both sides, just like multiply both sides by the ln. ln both sides. Okay, here's my 17. Here's my e to the 3x plus 4. To ln both sides, and if I have an ln and an e to a power on the inside, what comes out is just the 3x plus 4, because logs are exponents. And here's my ln 17, and this is saying e to what power gives me 17? We barely know anything about e. So again, cannot solve that any further. 3x is equal to ln 17. Again, that stays together. Divide both sides by 3, and I get this kind of messy looking answer, but that's my answer. Okay, so again, 4 examples, 2 with numbers, 1 with a common log base 10, 1 with a natural log base e. If I have an exponent, my goal is to essentially like multiply both sides, but I'm logging both sides with the same base. Okay, on the other side, same idea, just the opposite. So we had seen right up here, way in the beginning, if I have a log as an exponent and the base, this is the base that matches that base, this is the base, the log is the exponent that matches that base, then I can just pull out the exponent as we saw up there. So, or just pull out what's in parentheses rather. So over here, this is an invisible 10. So if I were to say 10 to the, and I make that log x plus 10, what's up top? Which is kind of weird. Again, same thing, 10 to the 3. So I take the equation and I just make them both the powers. Log base 10, which we don't see, x plus 10, x plus 1. Here's my 3, and I just say, well, I'm going to make both those the power. Both of those are the power. Well, as we saw before, logs are exponents, so logs are exponents. 10 to what power gives me this? I don't know. But if I put that power here, I'm going to get the log and the 10 to cancel. And here's my x plus 1. Just like if I were to say 10 to log of 100, right? Just like that, which we, a little review as we saw up there. We don't see a number here, so that's a 10. 10 to what power gives me 100? That's 2. So that means I could technically replace this whole thing with a 2, and I get my 100. So it always comes out to that number. Same thing, it always comes out to this. What is 10 to the third? Well, that's something we can compute. That's 1,000. Minus 1, minus 1. 999. Okay, so these are a little bit easier because a lot of times since we're canceling out the logs, we get all numbers. The other side, we were canceling out the numbers and we got logs. Okay, now next one over here, okay. ln, well, ln means for me e, but I want to get what's inside. I want to get what's inside. So I'm going to take e and make that the power, and take e and make that the power. Again, all I'm doing is taking my equation and saying e to that, because this is a natural log, e to that, and I get the ln and the e to cancel. 2x minus 1. What's e to the 9th? I have no idea. No idea. It's 2.7182 to the 9th. Doesn't matter. We're going to leave it like that for now, just like leaving it in terms of pi. Same idea. What's e to the 9th plus 1? I don't know. Divide that by 2. Divide everything by 2, and I'm going to get this in terms of e, just like in terms of pi. E to the 9th plus 1 all over 2. Okay, I think I have 2 more, and then the video is a little bit longer than I wanted, but I just want to get through some of these examples. And for those of you listening, maybe I'll just make up a word for the bonus, because I'm sure some of you just stopped listening at this point. Okay, again, same idea. This is a base 3 now, so we saw a 10, we saw an e, this is a base 3. If I had 3 to this power, I just take the whole thing, that's my exponent, and I take 3 and make that the whole power. I'm doing that so that my log and my 3 cancel. 3 to what power gives me this? I have no idea. But then 3 to that same power is going to give me that, right? And that's kind of what we saw. 3 squared I know is 9. The reason we didn't do this one up here because I didn't know what e to the 9th was. But I know what 3 squared is. It's 9. Nice, easy problem to solve. 14x is 7. Maybe my bonus, if you're listening now, maybe my bonus will be this. My favorite hockey player growing up was Sean Bates. He was number 17 on the Islanders. Sean Bates was my favorite hockey player growing up. If you're still listening to this, that's going to be the bonus on the next test. Test 2.3.2 rather. That's the bonus. If you're listening, that's what it'll be. Guaranteed. Okay, next one. Over here. Now we have a quadratic in there. Okay, but we do the exact same thing. This is the last one. This is a base 2. If I take 2 and I make that the whole power, take 2, make that the whole power. I'm doing that so that my log and my 2 cancel. I get x squared plus 3x minus 2 is equal to 2 to the third, 8. Well, now what? Same thing we always do whenever we have a quadratic. Make it equal to 0 so we can solve for both zeros, both solutions, both roots. Two numbers that multiply to 10 and that add to 3. There's no a value, so I can just do x plus 5, x minus 2. My answers are -5 and 2. So we can even solve a quadratic in logs. Okay, so that's the end of the video. You have a couple of these for practice for homework. Good luck. I'll see you guys Monday.